Types of condenser, introduction, components, working, advantages and disadvantages. What is a condenser? The condenser is a type of heat exchanger gadget, where vaporous substances are compressed into a fluid state utilizing a cooling agent and, then, at that point, latent heat is released in the climate. How does a condenser work? We should have a concise look at how a condenser functions. Once more, we need to specify that a full description of the part was committed to the subject of elements of a condenser. We convey the significance of how a condenser works to make it easier for you to comprehend what various kinds of this equipment are. 3 different phases happen in every condenser. The first phase is called desuperheating. The vapor going into the condenser is already superheated and supercompressed in the evaporator and compressor. Desuperheating means ejecting the heat and intensity from the vapor and transform it into liquid. The next level is changing or condensation state. Losing more heat continues in this state where we reach 10% of refrigerant as vapor and 90% as a liquid. The third and last stage is a subcooling state. The subcooling state is there in order to be certain that not, in any event, rising temperatures can bring the liquid refrigerant into vapor again. Components of condenser. Shell is the external surface and base of the condenser. Tubes are the primary part of the condenser, through that fume or gas is passed. Cooling agent. Cooling specialist. To create temperature distinction, and to ingest fume temperature, a cooling specialist is required. Coolant gulf. Coolant delta. A place, from where the coolant is placed into shell. Coolant outlet. A place, where used coolant is dropped from the shell. Fume inlet. A spot, where high-temperature fume is placed into the cylinders. Condensate outlet. A spot, where the dense fluid is dropped from the cylinder. Non-consolidating fume outlet. A place, where non-gathering fume is cruised by. Types of condenser. 1. Air-cooled condenser. This type of condensers uses air as the outer fluid to reject the heat and intensity from the framework. Air-cooled condensers normally have copper coils where refrigerant streams in. But this is not the whole story. This type is subcategorized into 2 subsets, natural convection and forced convection. A. Forced convection. One of the different types of condensers is constrained convection. A fan or a blower expects the most critical part in eliminating heat from the refrigerant inside the coils. Forced and constrained convection type condensers are normally utilized in window air control systems, water coolers, and packaged air conditioning plants. B. Natural convection. In this sort of condenser, air comes to contact with warm coils, absorbing the heat of refrigerant inside the coils. Subsequently, the temperature of air increases. As the warm air is lighter, it goes up and the cold air replaces, and again the cold air comes to touch warm coils to reject the heat and intensity. This natural cycle goes on until the refrigerant loses its heat. Since the flow rate of air is small and the radiation heat transfer is likewise not extremely high, the consolidated heat transfer coefficient in these condensers is small. Subsequently, a relatively large condensing surface is required to reject a given amount of heat and intensity. Consequently, these types of condensers are utilized for small-capacity refrigeration frameworks like household refrigerators and freezers. 2. Water-cooled condenser. This type or sort of condenser involves water as liquid to eliminate heat from the refrigerant. Clearly, water-cooled condensers are utilized where we have an adequate supply of water. This type itself has 3 different kinds. A. Double tube. Double tube condensers have a tube of water inside a huge refrigerant tube or cylinder. B. Shell and tube condensers. One of the sorts or types of condensers plays out the process of rejecting heat by having a cylindrical shell comprising of water tubes. In a shell and tube condenser, water is pumped through the pipes while refrigerant flows or streams in the shell. C. Shell and coil condensers. A welded shell contains a curl of thin water tubing in a shell and coil condenser. In this sort of water-cooled condenser, the hot refrigerant flows in the shell while the cooling water circulates inside the coils and condenses the refrigerant. It is all around compact and low in cost. 3. Evaporative condenser. The last one of the type of condenser is the evaporative one. Evaporative condensers use air and water as the consolidating medium. The condenser sump pumps the water to be showered over coils, and simultaneously, a fan blows the air into the condenser. The sprayed water over the coil evaporates, and the necessary heat and intensity for the vaporizing water are taken from the heat of the refrigerant. Comparison between these three types. Evaporative are utilized where we generally experience a water supply shortage. Evaporative are kept outside, so in chilly seasons, the water pump is switched off in order to forestall freezing water. Air-cooled condensers contrasted with water-cooled ones are straightforward in development. In addition, admittance to air is generally accessible. Advantages of condenser. It builds the extension proportion of steam, and subsequently increases the productivity of the plant. It lessens the back pressure of the steam, and subsequently, more work can be acquired. It lessens the temperature of the exhaust steam, and it increases the work proficiency. The reuse of condensate as feed water for the boilers lessens the expense of power generation. Disadvantages of condenser. Need an adequate supply of fresh water. It isn't easy to repair, hence you should watch out and need to be careful. Corrosion. Requires more space. Conclusion. The petrol and chemical industries utilize condensers for the buildup of hydrocarbons and other substance fumes. The arrangement of the condenser expands the capital cost of the power plant. Since it needs a condenser, the allied pump to work or operate the condenser, the hot well, and the cooling tower. In any case, the increased capital expense is counterbalanced in an extremely short time frame because of the increased productivity of the power plant. Knowing the types of condensers assists you with having a better decision at the time of purchase. Thanks for watching.